In this project, you will build a fun and highly addictive LED reaction game. The goal is to press the push button switch at the exact moment when you see the red LED lit. This isn't as easy as it seems because the LEDs are going on and off at random times and in a random sequence. We will be learning how to apply interrupts to react to events in our circuit. That is how we will know when the button has been pressed. Let's take a look at the objectives for our project. By successfully completing this project, we will have mastered the following items. We will learn how to incorporate interrupts as an important process of detecting and reacting to events in our electronics projects. We will also be introduced to the random Arduino function for creating random numbers. If you're ready to begin, let's get this project started. Here are the parts that we will need: an Arduino Uno, a USB cable, a breadboard, 3 220 ohm resistors and a 1 kilo ohm resistor, 3 LEDs, a red, green, and a yellow preferably, or any 3 different colors, a push button switch, and connecting wires. Let's take a look at our circuit diagram. As you can see, we have 3 resistors that are connected, which are 220 ohms to our LEDs. The resistors are connected to the ground rail, and they are connected from the cathode, or the negative shorter pin of our LEDs. From the anode of the first yellow LED, that goes to pin 10 on the Arduino. The anode on the second red LED, or the center one, goes to pin 9 on the Arduino. And finally, the anode of the green LED goes to pin 8 on the Arduino. For our push button switch, when under the switch goes to pin 2 on the Arduino, there's also a 1 kilo ohm resistor. That's a pull-up resistor connected to the 5-volt rail. And then the other end of the switch goes to ground. The final connection is from the 5-volt pin on the Arduino to the 5-volt rail. That completes our circuit diagram. Let's go ahead and connect our circuit. First, we're going to have our yellow LED. Next, our red LED. And then finally, our green LED. Then we can connect our 220 ohm resistors. Remember, those resistors go from the cathode to ground, or the shorter pin of the LED to ground. That's the first one. Finally, the third one. Next, let's connect the ground rail. So we're going from ground on the Arduino to the ground rail. Then we'll make the connections for the LEDs from the anode. So first for the yellow, that one goes to pin 10 on the Arduino. For the red, goes to pin 9, and for the green, goes to pin 8. We'll now connect our push button switch. one end of the switch goes to ground. So we'll make that connection now. The other end has a 1K resistor. That's going to go to the 5-volt rail. And there's another connection that goes to pin 2 on the Arduino. And the final connection that we have to make here is from the 5 volts to the 5-volt rail. Alright, that completes the wiring of our circuit. Alright, let's go ahead and upload the code. Alright, so when that's done, so what you'll notice is you'll see the LEDs flashing in a random manner. And the objective is to hit this push button switch at the exact time that we see the red LED lit. So if we try and we're not successful, you'll see the LEDs continue lighting. But if we're able to do it, like I just did, all 3 LEDs would flash. So that's how we know we've won, and we've successfully sort of hit the switch at the exact moment when the red LED was lit. I'll try it one more time. Missed there. I got it. So we'll take a look at how we can manipulate the randomness of when the LEDs are on and off and the time or duration between which the LEDs are lit to make the game more difficult. But a very interesting game, and it's actually highly addictive. Okay, let's go ahead and take a look at the code. First, at the top, we define our LEDs. So we have our green LED, which is connected to pin 8 on the Arduino, our red LED to pin 9, and the yellow LED to pin 10. If you didn't have green, red, or yellow, you can change these variables to depending on the color of LEDs that you have, but that's how we initially set up the LEDs and which pins they're connected to. Next, we have an array for times on. So you can make this, as big as you want it. Initially, it's set up with these 4 values, and this is the duration in milliseconds that the LEDs would be lit. So as you'll see later on, what we do is to get that randomness, we generate a random number and pick from one of these 2 values. This is 1/10 of a second to 1/4 of a second, all the way up to 1/2 of a second. So you could tweak this and make different values in between here to change your randomness of the times that your LEDs are on. Next is also an array for delay times, and this is the random waiting period between which the LEDs are lit. So again, I have 4 random values here, 1/4 of a second, 1/2 of a second, 1 second, and 1.5 seconds. So remember, these values are in milliseconds, so you can add to these or tweak these accordingly to change the complexity of the game. Next, we have a couple of global variables that we declare that we want to access and set in our interrupt service routine. So red LED lit, we want to keep track of when the red LED is lit so that when you press the button, we could determine when that is. And if you were a winner, we want to keep track of that. Notice with these 2 variables, we have to declare them as volatile. And the reason is because this is done so that they can be accessed and modified within your interrupt service routine. So just be mindful of that. Then comes our setup function. We set our LEDs as output. You've seen this before. And here's where we create our interrupt. Since we have attached that switch to pin 2 on the Arduino, we define that as the 0 interrupt. We specify our ISR, interrupt service routine function, check winner, and we want that to happen on the falling. So when we push our switch, and we go from a high to a low voltage, that's when we want to interrupt the fire. We initially turn off all our LEDs, and there's a convenience function that I created, turn off LEDs, so I'll quickly go to that to show you what that looks like. Basically, in that function, we do a digital write to all the LEDs, turning them low, so that turns off our LEDs. So let's look at our loop function. First, we want to pick a LED to light, so we use the random function, and random will allow us to pick a value between 1 and 3 here. We also want to pick the time that the LED is lit. So again, we use a random function, the random function. This will generate a random number between 0 and 3. And we pass that into the array to get our times on array, which we defined above, to pick one of these random times. So it would result in one of those random times there. So if we've determined which LED we're going to light, and we've determined what period the LED is going to be on, then we proceed to light that LED. So we call the light LED function, passing in the LED that we want to light, right? That which would be 1, 2, or 3, those values corresponding to yellow, red, or green. And then we pass in the time that we want to light that LED for. So let's quickly jump to this light LED function. So as you can see here, it takes these two arguments, the LED that we're going to light. 1 corresponds to green, 2 to red, 3 to yellow, and the duration in milliseconds that we want to light it for. So when this function is called, basically we have a switch statement here. If your LED was 1, that's a green one, we hit on there, we do a digital write green LED high, that's gonna light that green LED, and similarly, if it was 2 that was passed in, we set the red LED high. Also, the red LED is important. So in this function, we also want to change that flag to red LED lit to true. So we want to keep that sort of as a global variable, saying that right now at this point in time, our red LED is lit. After this, we're going to wait. So we're going to put delay duration. Remember, we had passed in the time that we want the LED to stay lit. So we delay for that time. And if an interrupt didn't occur, we put red LED lit false. So we switch it back to false. So that is our light LED function. Then we turn off all the LEDs. So again, this just sets them to off. Next, we want to wait a random period of time that the LEDs are off, and this would make the game unpredictable. So similarly, we get a random number between 0 and 3. We get a random time from our delay times array, and we delay for that random time. What we do then is we check after that if is winner. Basically, if that is winner flag is set to true, we want to invalidate it as winner is false, and we call the winner function, which would cause the LEDs to light up 3 times. Right, so here in the winner function, this is where we do the 3 flashes in quick succession. So we turn the LEDs high, we wait for a quarter of a second, turn them low, and we do that for 3 times. Right, we loop in here 3 times, and then we delay for 3 seconds. So that's a winner. So how is a winner determined? Well, when you push the push button switch and our interrupt service routine check winner is called, let's go down to check winner. All check winner does is it checks at that point in time. Remember, wherever you are in the code, it's going to jump into here to service our interrupt service routine. So if red LED lit is true, we set that global is winner flag, and that is how in our main loop, if that flag was set, we know you have won. So we indicate that you have won, and we set it back to false. So quite a lot going on here, but take the time to go through the code, and hopefully that explains the operation of our circuit. Let's take a look at the Arduino random function to get the documentation. So here, as you'll notice, random can be There are two different forms of it, and actually we have used these two different variations in our program. It can take one argument, random max, and max is the upper bound of the random value you want to generate, exclusive, meaning it would not be included. So for example, if you call random passing in 3 as your argument, it will generate a number that's 0, 1, or 2 and exclude 3. So your random range will be 0, 1, or 2 will be a possible list of random values. The next way to call a random function would be random passing in a min and a max value, and min is the lower bound of the random value inclusive. That means it could potentially also be included. So let's say we call this random function passing in 1, 4. It would return to us a list of possible random values that are 1, 2, or 3. Remember, 4 would be excluded, so your options would be 1, 2, or 3. So hopefully that explains the random function, and just wanted to take a look at the documentation to clear that up for you. To summarize, in this project, you learned how to apply an interrupt to detect important events in your circuit. You were also introduced to the random function for generating random numbers. Our game is addictive. Feel free to play some more, and then we can jump into our next and equally fun project.